Today we are going to look into another interesting topic called calendar. So to do with the basics in calendar, nowadays we are following an Gregorian or an Western calendar. So that is the calendar which is popular throughout the world. In calendar, the very basic is we need to find the number of odd days. Only with this odd days calculation we can proceed further with the problem. So in every other problem, only based on the number of odd days, we can calculate the any day or date which is not mentioned. So what do you mean by odd days? Odd days, the days which is left out of the week, we can say it that way. That is called as an odd day or an extra day. We can say very clear, that is extra days. That is the day which is left out of the week. Say for example, if you're given with 8 days, how to find the number of odd days in this 8 days? 8 days, you can divide this 8 days, that is equal to 7 days. 7 days which form 1 week, plus that 1 day is extra. That extra day is supposed to be an odd day here. So in 8 days you have 1 odd day. This is how we calculate the odd days. Similarly, if it is 31 days, how to calculate odd days in the number of 31 days? Again, divide 31 by 7. Once you divide the value by 7, you will get the remainder as 3, that is the extra days. So this extra days is termed as odd days. So on the whole, if there are 31 days, we'll have 3 odd days. And the same thing, the same example, if we have 286 days, on the whole you are given with 286 days. How to calculate the number of odd days? You have to divide the value by 7 and the remainder value is taken as the extra days. Why we are dividing the value by 7? The reason is 7 days forms 1 week. So 1 week is counted together and all the remaining days or all the extra days is termed as odd days. So odd days calculation is the very basic thing to proceed with. See, and another basic part is first we know the ordinary year or the normal year. We can say it as a normal year. A normal year has 365 days. We all know it, obviously. So 365 days, and how to calculate number of odd days in this 365 days? The same rule. You have to divide that number of days by 7. So divide 365 by 7. You will get the quotient as 52. As you see in this slide, see, while dividing, the quotient value is 52 and the remainder is 1. That is 52 weeks. The quotient value gives the number of weeks because they are the multiple of 7. 7 days gives you 1 week. So if there are 52, then it means that there are 52 weeks and the remainder is 1. So this extra day is termed as an odd day. So in an ordinary year, we have 52 weeks and 1 extra day which is an odd day. Suppose if we take it as a leap year. Leap year, the case is different because in leap year we have on the whole 366 days, isn't it? 1 day will be extra because in ordinary year or in the normal year, the month of February usually has 28 days, whereas if it is a leap year, then the month of February has 29 days. So 1 day is added. So we'll get the total number of days as 366. Divide the value by 7. You'll get the same, that is 52 weeks plus the remainder will be 2. Not because 1 day is added in the month of February. So 2 extra days. So the 2 extra days is termed as odd days. So in an ordinary year, we'll always come across 1 odd day. If it is a leap year, we have 2 odd days. Okay, then how to find out? That is, you are given with the year, say 1982 or 1983. How to find out that this year is leap year or not? Instantly, isn't it? That is the other question. So if you are given with any year, just very simple, divide the year by 4. That is the first case what we usually do. We'll divide it by 4. If the remainder is 0, we'll say that it is an exact multiple of 4. So the given year is a leap year. That is what the straight way calculation. But why we are dividing the value by 4? why we are dividing the value by 4 to say that this particular year is a leap year or not. The reason is every fourth year will be a leap year, isn't it? If 2000 is a leap year, then every fourth year from 2000, fourth year will be 2004. Definitely that 2004 will also be a leap year. So every fourth year should be a leap year. That is our calculation. So based on this, to find the a leap year, whether the given year, whether the particular year is leap year or not, we used to divide the given year, given value by 4. That is the straightway calculation. But we need to follow a step-by-step procedure to say that the given year is a leap year or not. Say step 1. Step 1, first better divide the value by 400. Is that clear? You have to divide the given year by 400, and if the remainder is 0, then definitely that particular year should be a leap year. That is step 1. Step 2, if you have to divide the year by 100. You have to divide the year by 100, and if the remainder is 0, then we can definitely say that it is not a leap year, provided that particular year should be divided by 400, but it should not be divided by 100. That is, it should be an exact multiple of 400. At the same time, it should not be the multiple of 100. Then that year is said to be a leap year. So this is the very must thing what we have to remember for perfect centuries. Okay, we'll go ahead with the calculation. See, this is a simple one. They have given some examples. See, 1982, 2012, 2010, etc. So I need to find whether this year is leap year or not. For 1982, again, you have to divide this value by 4. Again, we'll follow a numerical shortcut method. That is, instead of dividing all the 4 digits by 4, we can just extract the last 2 digit from the year. That is the 4-digit value, 1982. We are going to extract the last 2 digits, which is 82, and I can divide it by 4 just to simplify my calculation. No need to take all the 4 digits and divide it by 4. That is the shortcut method for dividing by 4. I hope that you may have come across this shortcut methods. So here I am dividing this 82 by 4. I used to found that the remainder is not equal to 0. Isn't it? 82 is not a multiple of 4. So it is not a leap year. Next, going to 2012. Take this last 2 digit, that is 12, divided by 4. You will get the remainder as 0. So that must be a leap year. Next, 2010. Last 2 digit, that is, I am going to extract the last 2 digit, that is 10. Divide the value by 4. I think a 10 is not a multiple of 4, so it is not a leap year. Likewise, we can predict whether the given year is leap year or not. Okay, and for perfect centuries, see this goes with the normal years. Suppose if perfect centuries are given, say 1600, that is the year with end up with last 2 zeros, 1600, 1700, 1800, last 2 digits are zeros. We'll say if the last 2 digits are zeros, we could not directly say, that is dividing it by 4 will never work out here. So where we have to, if it is a perfect century and if we need to find whether that century is a leap year or not, then you go with divide the value by 400. It is not 4, you have to divide it by 400 in case if the year are perfect centuries. Okay, 1600, if it is a century actually, not perfect century, it's a century. So 1600, 1700, 1800, all the years with ends up with 2 zeros or centuries, isn't it? And if it is a century, then to find out whether that century is a leap year or not, we have to divide it by 400 instead of 4. So only if the century gets divided by 400, then we can say that that particular century is a leap year. If it is a normal year other than centuries, we can straight away divide it by 4 and we can predict, whereas in case of centuries, you have to divide the value by 400. Okay, and odd days is extra days, what we have seen earlier. Okay, so how many extra days you have? It is termed as an odd days. See other few examples here. I have given the years. I have mentioned only the last two digits over here. 1988 were 88, 2002, 2012, 1985, 64, 2015, 166 and 544. So to find, there is no century in this series. So straight away we'll extract the last two digit. Let we divide the value by 4 and let us try to find out whether the remainder is 0. If the remainder is 0, I can say that this particular year is a leap year. So here the colored numbers, see I have highlighted using a red color. The red color numbers, it indicates that particular text indicates that that is a leap year. 88 is an exact multiple of 4, and in 2012 12 is a multiple of 4, 64 is multiple of 4, again 44 is the multiple of 4. So while you divide this value by 4, you will seek the remainder as 0. So we can say that those years are leap years. Okay, then I say how to find the number of leap years. I have given you with some 90 years or 100 years. Tell me how many leap years in 100 years. Or I can ask, tell me how many leap years are there in 86 years or 96 years. We can straight ask questions in this way. So how to find out the number of leap years? Again, it is another task where it is very simple. See, if there are 83 years, one good example is here. If there are 83 years, say from year 1 AD till 83, 1, 2, 3, etc. up to 80, 81, 82, 83. So we have how many years now? 83 years altogether. So to find the number of leap years in this 83 years, if it is a leap year, go divide the value by 4. So divide 83 by 4. Once you divide the value by 4, you will get the quotient as 20. That quotient value should be taken or should be considered as the number of leap years in those years. So in 83 years altogether, we have 20 leap years. So the rest part, that is the remainder part, should obviously be the normal year or an ordinary year. Okay, so this is how you can find the number of leap years. And very basic is odd days, that is the extra days or the days which is left out of the week. They are termed as odd days, isn't it? So if there exist 100 years, how many odd days will be there? They have given that 5 odd days. I'll give you an clarification, a clear-cut explanation for these odd days in the forthcoming slides. And before that, let me have a short review on it. That is, 100 years have 5 odd days, 200 years have 3 odd days, 300 years have 1 odd day, and 400 years have 0 odd day. You have to remember. If you remember it, we no need to waste our time. We can quickly solve the problems. So better remember the values for these centuries for 100, 200, 300, and 400. It is 5310. Or another easy way to remember, just in a paper, put up the numbers 5, 4, 3, 2, 1, 0. Okay, and for 100 years we can directly mention that there exist 5 odd days. Strike out the value 4. The next value is 3. So for 200 years you have 3 odd days. And strike out the value 2, and for 300 years we have 1 odd day, and the rest value only 0 is available there. That 0 can be straightly matched to 400 years. This is how you can remember the odd days in those centuries. Okay, and century, if it is a century or a leap year, definitely there will be and century and a leap year, both the things should get fit into that a year. That is, that particular year should be a century as well as it should be a leap year. So if this is the case, then that particular year have 0 odd days. See, and this slide shows the days corresponding to the odd days. See, if the odd day, that is, if the odd day is 0, then what is the day? Sunday. If the odd day corresponds to 1, then the relevant day will be Monday. Likewise, it proceeds till Saturday up to 6. So we have 0 to 6 altogether, 7 values, because all the odd days should be a multiple of 7, and the value should come below 7 If it exceeds that value, then you go for dividing it by 7 and we'll find the perfect match. So 0 to 6. So odd days 0 to 6 and the corresponding days for the numbers are given. And for each month also we can remember the number of odd days. See, for January there is 3 odd days. How come we calculate the number of odd days for a month? See, in January we have 31 days. Yes, divide 31 by 7 because all the things are the multiple of 7 because 7 days constitute 1 week. So 31 days, so divided by 7, you'll get the remainder as 3. So that remainder or the extra days is the odd day. Similarly, assume that there's any year maybe that I have assumed that year is not a leap year. So February has 28 days. Divide the value by 7. 28 is an exact multiple of 7. So the remainder is 0. So Feb has 0 odd day. So this is how we can calculate the odd days for every particular month. Okay. So odd days, how to match the odd days and how to calculate the odd days for every month has been given. Yes. Again, coming to the previous slide, see in this slide we have mentioned that in 100 years or in a century, we have 5 odd days. That particular calculation is given in this slide. See, a century you have 100 years. Among 100 years, we need to find how many ordinary years and how many leap years. So to find out that, we have to divide 100 by 7. If you divide the value by 7, we'll get 76 ordinary years plus 25. 25 leap year will be there. You'll get the value not as 24, you'll get 25. But I have excluded the last year, which is the 100th year, because 100 is not a leap year. That 100th year is not a leap year because it is not divisible by 400. I have already mentioned you that if it is a century, then that particular year should be divisible by 400, isn't it? So if but that 100th year is a century, but it is not divisible by 400, so that is not a leap year. So in 100 years you have 76 ordinary years. Even though we have 25 leap year, in 25 they have included that 100th year. Including that 100th year, it shows that there are 25 leap years, but we should not include. So minus 25 minus 1, so it is 24 leap years. So in 100 years we have 76 ordinary years and 24 leap years. And as an ordinary year, how many odd days are there in ordinary years? See, we have already seen ordinary year we have, look at here, we have 1 odd day. If it is a leap year, we have 2 odd days. So 76 ordinary year. So number of odd days is 76 into 1. And leap year have how many odd days? 2 odd days. So 24 into 2. That is 76 plus 48, which is 124 odd days. Just divide this value by 7. Again 124, it exceeds, so divide it by 7. You will get 17 weeks plus 5 odd days. So in a century, how many odd days are there? 5 odd days. This is the calculation. This is how they have calculated the odd days for 100 years, 200, 300, 400. And I have straight away mentioned you that 400 years have 0 odd days. I'll give you the explanation for another 200, 300 and 400 century also in the next slide. Okay. And always the last day of a century will be Friday, Wednesday, Monday or Sunday. You have to remember it because these questions been asked in the competitive exams. The last day of a century will be Friday, Wednesday, Monday or Sunday. It definitely occurs in among these days only. See, we have seen for 100 years, I have told you that 100 years we have 5 odd days. Similarly, see how we have calculated for 200 years. You have to split 200 into 2 parts. 100 plus 100. 100 plus 100, 200. So in 100 years, how many odd days we have? 5 odd days. Another 100 years, again 5. 5 plus 5, 10 odd days. Again it is more than value of 6 or 7. So divide 10 by 7. The remainder is 3. So 200 years have how many odd days? 3 odd days. And coming to 300 years, 300 can be splitted into 200 plus 100. 200 years have 3 odd days, which we have calculated already, plus 100 years have 5 odd days, So 5 plus 3 again 8. 8 again it exceeds the value. So divided by 7, we'll get the remainder as 1 odd day. So 300 years have 1 odd day. And 400, see 400, it is century and also it is a leap year. Mind that. So if the year is given, if it is a century and it is a leap year, then definitely it has 0 odd days. We have to remember that. No other go. So 400 can be split into 300 plus 100. For 300 we have calculated that there are 1 odd day, plus 100 years have 5 odd days. 5 odd days. Plus you can wonder why I have mentioned this extra 1 odd day. The reason is 400th year is an what? 400th year, that is a leap year. Ordinary year have only 1 odd day, which we have mentioned here, but leap year has 2 odd days. So we have left out that 1 odd day. So I have added 1 odd day over here, because 400th year is a leap year. Leap year has 2 odd days. 1 odd day is been included because it comes under ordinary years, but as a leap year it has 2 odd days. So I have to add another extra 1 odd day. Okay. So 5 plus 1, 6 plus 1, 7. 7 is an exact multiple of 7. It is the remainder is 0. Therefore 400 years have 0 odd days. Or I can say that all the perfect centuries will have 0 odd days. Clear? Right. Okay. Next, finding the day. Now straight away we'll move into the problem. So still now we have looked into some basics, and now the first problem is finding the day when another day or date is given. That is, it will be given. Simply they'll ask, what was the day on 26th April 1986? That was the common question, isn't it? So how to find out that particular day? See, I'll tell you first the normal method of calculating this, and alternate way, that is the doomsday algorithm for calculating this, and whichever is better or whichever suits you, whichever you feel very much easier, you can follow that. So I'll give you both the methods for calculating this kind of problem. Okay, so when another day or date is not given. Okay, before that, let me look into a simple problem. See, first example. Today is a Monday. What will be the day 61 days later? Okay, today is a Monday. What will be the day 61 days later? That is Monday plus 61. Okay, 61 days later. So Monday plus 61. So take that Monday as it is, and 61 days are there. Divide 61 because we need to find the number of odd days. So divide 61 by 7. You will get the number of odd days as 5. Monday plus 5 odd days. That is after Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So 61 days later, that day will be a Saturday. So every calculation depends upon the odd day calculations. So once you calculate the number of odd days, then we can easily match up with the exact day. Clear? Next, if 17th March 2008 was a Monday, what day was 1st April 2012? See, remember, while you look at the question, look at the year. If they belong to the same year, straight away you have to calculate the odd days for each and every individual month, and from that we can solve the problem. But the year is different. Say in 2008, as that of this problem. See here, 17th March 2008, that was Monday. But what was the day of 1st April 2012? That is 4 years ahead we are. 4 years ahead. And that was the month of March, and the question was asked in the month of April. And the day also varies. See, that was 17th March and they are asking for 1st April. So you have to look into all these constraints before letting into the problem. See first, 17th March 2008 to 17th March 2012. So I need to find the number of days, the difference between these 2 years, from 2008 to 2012, March to March, 17 to 17. Okay, so I need to find the number of days in this, and after that from 17th March to once I find out the day of 17th March 2012, from there I can approach with 1st April. That is, from there I can find the difference between 17th March 2012 and 1st April 2012. Okay, this is the two step in calculating the problem. See, so first I have to calculate the day of 17th March 2012. Already 17th March 2008 was given as Monday, so I am adding that Monday plus after 2008 the year is 2009. Why I have added 1 over here? Because 2009, just check it whether it is an ordinary year or a leap year. 2009 is an ordinary year, so I have added 1 odd day. Next, coming to 2010, again 2010 is an ordinary year, so I have added 1 odd day. 2011 is an ordinary year, so 1 odd day. 2012 is a leap year, so I have added 2 odd days. Yes, now we have traveled from 2008 to 2012. Right? So Monday plus 1 plus 1 plus 1 plus 2, adding together Monday plus 5. Monday plus 5, if you add 5 to Monday, you will get the value as Saturday. So now we found out that 17th March 2012 was Saturday. But that was not the final answer. What we need to calculate is, we have to calculate what day was 1st April 2012. Okay, if 17th March 2012 was Saturday, isn't it? 17th March 2012 was Saturday. What was the day? 1st March. So you have to find the difference between these 2 days. That is from 17th March to 1st April. The difference is 15 days. If you calculate, you will get this answer. The difference is 15 days. So 15, again it exceeds the value, so better divide the value by 7, because the value should lie between 0 to 6, so that we can exactly say the day. So dividing it by 7, the remainder is 1. So Saturday plus 1 day, yes, Saturday, add 1 day to Saturday, it is always Sunday. So the answer is, that is 1st April 2012 was Sunday. Clear? Yes. Next one. Which year? Yes, this is the most commonly asked question in the competitive exams. Which year will have the exact same calendar as 2009? Yes, 2009 we will come across one particular pattern of calendar where the day and the date are same. The day and the date, there will be in a particular pattern, and which year, which forthcoming year will have the same calendar as that of 2009. That was asked in the question. See, 2009, if they ask in that such a way, what you have to do is, from 2009 you have to add the number of odd days, and once the number of odd days sum up to the value of 7, because why it is 7? Because 7 is an exact multiple, so the remainder will be 0. So 2009 you have 1 odd day. Again 2010, it's not a leap year, so again another 1 odd day. 2011, it is also not a leap year, so it is an ordinary year, so you have to add 1 odd day. 2012 is a leap year, so we have added 2 odd days. 2013 is not a leap year, so 1 odd day. 2014 is also not a leap year, so it is 1 odd day. I have stopped here. The reason is, once you sum up the values, 1 plus 1 plus 1 3 plus 2 5, 5 plus 2 7. I got the value of 7. Once I divide 7 by 7, the remainder is 0. So if the remainder is 0, definitely the forthcoming year, that is the year after 2014, which is 2015, will be the same as that of 2009. So the year 2015 and 2009 will have the exact same calendar. So you need to find the difference and the difference value, that is, you need to find the number of odd days, and the number of odd days should sum up to the value of 7. You should not say that 2014 is that will have the exact same calendar as that of 2009, because once you take into account, this particular year has been taken into account, so we should not consider this year, only the year after it, that is after 2014 we have 2015. So 2015 will going to have the same calendar as that of 2009. Okay. And another one is finding the day when another day or date is not given. Again, as I already mentioned you, that we have 2 ways of solving this problem. First, I let you know the normal method of solving this, and the next thing will come to the doomsday part. So how normally we can, what is the normal method of solving it? What day of the week was 17th August 1983? See, this was the question. how to solve this or how to find arrive at the answer. See, the normal method is first take this year 1983. I'll quote you. Say take this year 1983. Wait, I'll give you an view of it. How we are dividing it. See, I have taken 1983. What we have to do is minus 1. Do one thing. 1983. Subtract 1 from this year. 1983 minus 1. So it is 1982. So divide this year into two parts. One is 1982 and the other one is 1983. This year let it be remains the same. We are not going to touch 1983 now. Now let us start simplifying this 1982. How to divide this 1982? What I can do is I can take 1600. I'll tell you why I am doing that. Plus 300 plus 82. We can split like this. The reason is, see, 1600. I have to take 1900. So once you go with 1900, I have to find the exact perfect century. That is, it must be a century and it must also be a leap year. So before 1900, I could not take 1800 because that is not a leap year. I could not take 1700 also because that is also not a leap year. So I have taken 1600 because it is a century as well as it is a leap year. So I have considered 1600. Again, the remainder years, 300 years are there. 1600 plus 300 will sum up to 1900. The rest part is 82 years. I have simply written that 82 years. Okay. So again in 1600 years, it is a perfect century. As I already told you that 1006 it is a century and also a leap year. So the number of odd days is equal to 0. 1600 years have 0 odd days. And for 300 years, as we have calculated already, 300 years have 1 odd day. And in 82 years, so if number of years are given, to calculate the number of odd days for 82 years provided, again divide the value of 82 by 7. If you divide the value by 7, again we'll get this answer, that is 20 leap year and 62 ordinary years. Okay, and if it is a leap year, I told you that the number of odd days is 2, and if it is an ordinary year, you have the number of odd day as 1. So since in 82 years we have 20 leap years and 62 ordinary years, so 20 into 2 plus 62 into 1, altogether we have 102 odd days. Divide the value by 7, again you'll get the remainder. Yes, 102. Once you divide the value 102 by 7, you'll get the remainder as 4. So 82 years have 4 odd days. Is it clear now? See, 1600 year, it is both a century and a leap year. So it has 0 odd days. 300 years have 1 odd day, which we have seen already. And in 82 years, first you have to find how many normal years and how many leap years are there in 82 years. So to calculate that, I need to divide the value of 82 by 7. Once I divide it by 7, I get the answer as 20 leap years and 62 ordinary years. If it is a leap year, the number of odd days is equal to 2, and if it is an ordinary year, the number of odd days is 1. Do this calculation. So it is 102 odd day, again divided by 7, you will get 4 odd days. So 82 years have how many odd days? 4 odd days. Again, now 1982, that one part is over. Next we are coming to the year 1983, because we have divided this year into two parts, isn't it? 1982 and 1983. Still 1982 we have calculated the number of odd days. So for 1983 we need to calculate the number of odd days. And how to calculate the number of odd days for 1983? This is done. See, in 1983 also they have mentioned the month, that is it is 17th August. So till 17th August we need to calculate the number of odd days. We cannot say straight away that 1983 it is not a leap year, so I can say that the number of odd days is equal to 1. No, we can't do that, because the 1983 also we cannot take on the whole the one particular year. Again there is a break that they have asked till 17th August 1983. So till 17th August we need to calculate the number of odd days, right from January till August. Okay, we need to calculate the number of odd days. As I told you that, see, to calculate the number of odd days in January, Just try to find out the number of days in January. It is 31. Feb, it is 28. So you can go in that way, or you can use the table, see, whichever I have given in the previous slides. Yeah, this one. You can make use of this table and you can sum up the value. January 3, I'm sorry. Yeah, January 3, Feb, March, April, May, June, July. Till July I have to take, isn't it? So it is 3 plus 3, 6, 2, 8, 11, plus 2, 13, plus 3, 16. Likewise, we can directly add 16, and from that I have to add 17 days. Again 16 plus 17. So 16 plus 17 will sum up to 33. So once you divide 33 by 7, 28, the remainder will be 5 odd days. Clear? 5 odd days. Or you could not remember those number of odd days in a particular month. See, you can have this calculation. In January, just write the number of days in January, Feb, March, April, May, June, July. And August, I am not taking the whole day because they have given it is 17th August. So I have taken the value directly as 17. So add all these values and divide it by 7, you will get the number of odd days. Both are correct. Okay, so totally, now tell me total number of odd days. See, here it is 0 odd day. For 300 years we have 1 odd day. For 82 years we have 4 odd days, and till 17th August 1983 we have 5 odd days. Total summed up together, there comes 10 odd days. Again 10 by 7, that is 10 divided by 7, you will get 3 odd days, and the value 3. The value 3 corresponds to which day? See, the value 3 corresponds to Wednesday. So the answer is Wednesday. See, this is the very lengthier calculation. Since you have to divide it value, you have to find the number of odd days individually, finally you have to sum up together, and finally you arrive at an answer where it grabs a lot of your time. So what is an alternate way of solving this problem? That way is called as an doomsday method. We can call that day as doomsday algorithm. See, doomsday, which days are referred as doomsday? That is, you have to remember this. See, the last day of February, 4th April, 6th June, 8th August, 10th October and 12th December. Or the easier way to remember this doomsday is 4/4, 6/6, 8/8, 10/10, 12/12. These days are doomsday. These days are doomsday in any year. So if once you calculate the doomsday, from that we can arrive at the particular day or the date whichever mentioned in the problem. So these are the doomsdays. So what is that algorithm meant for? See, there is a formula. Actually, you have to remember this formula. That is doomsday for a year. It can be calculated using a formula. In that formula, the first parameter is anchor. Anchor is again it is a day. For every century there will be an anchor. Okay, that is given. I have given anchor for 2 different years. See, from 1900 to 1999, the anchor will be Wednesday. So all the years which lies in between this range, you can write the anchor as Wednesday. And if the year is about 2000, they have given like 2010, 2012 or 2017 likewise. So from 2000 to 2099, so in this range, if the year lies in this range, then the anchor what you have to substitute is Tuesday. I think these two will good enough to solve the problems because they will ask merely in these ranges only. So for the first one, 19th century, the anchor is Wednesday. In 20th century, the anchor is Tuesday. But I try to remember this anchors because that is substituted in the formula. So doomsday for a year is equal to anchor plus year, that particular year, whatever given in the problem should be divided by 12 plus once you divide that value by 12, you'll be getting a remainder value, isn't it? You have to add that remainder value. Again, that remainder value, what you got by dividing the number by 12, that remainder value should be divided by 4. So once taking all these values sum up, you will get the doomsday. Once we find out the doomsday, we can easily arrive at an answer. So I'll give you an example for this doomsday. Yeah, here it is. How the same problem. Okay, look at See what same thing, 17th August 1983. Same problem we are approaching in a different way. So 1983, so it lies in 19th century. So the anchor is Wednesday. Plus the year, I have already told you that if it is an year, please do take only the last two digits. Here also we are going to take the last two digits. So 83 by 12 plus the remainder of that value, plus that remainder should be divided by 4. Wednesday, once you divide 83 by 12, you will get the quotient as 6, the remainder as 11, and once you divide this remainder by 4, you will get the quotient as 2. Add all these values. So Wednesday plus 19 again it exceeds the value of 7, so divided by 7, you will get 5 as the remainder. So Wednesday plus 5, add 5 days to Wednesday, you will get Monday. That Monday is the doomsday. That Monday is referred as the doomsday. That is doomsday. Now try to find out the nearest day, nearest doomsday for this date. What was the date given in the problem? 17th August is given in the problem. I told you that August, the doomsday are 8th August. 8th August is nearest to 17th August, isn't it? So I can take 8th August. 8. So 8th August is Monday. That is the doomsday. Now I have calculated the doomsday. Now what is the day asked in the problem? 17th August. Yes. Now try to find out the difference between 17 and 8. 17 minus 8, it is 9. So add that 9 to Monday. Monday plus 9, or simple, divide 9 by 7, you will get the remainder 2. Monday plus 2, Monday, Tuesday, Wednesday. So the answer is Wednesday. So within 2 to 3 seconds, I think we can solve this problem. Suppose if you choose the previous way, then it takes nearly 10 to 15 minutes to arrive at an answer. So better you can save your time by following this method, doomsday algorithm method, to calculate a particular day. Is it clear? So both the methods are mentioned here. You can follow the method whichever is easier to you. And the last problem is, if January 1 is a Tuesday, what day is August 26? Isn't it? So they have given, see, the year is same, but the year is not mentioned here. So if the year is not mentioned, assume that it is an ordinary year. Okay. So in the same year, what they have given, 1st January is Tuesday, then what day will be 26th August? That is asked in the question. So since January has 30 more days, because 1st January is taken into account, so already January has 31 days, 1st January is taken into account, so I am subtracting. Leaving 1, it has how many days left? 30 more days. So try to find out the remainder. Just the number of odd days. See, in January the number of odd days is 2. Yes, because I have taken only 30 days. If it is 31, then the number of odd days will be 33. In February, it is 28 days, so the odd days is 0. In March, the same thing. See, the same calendar, the same table. In March, I have 3 odd days. April 2, May 3, June 2, July 3, August 3. That's what I have taken here. July. And August, I am not considering it because that is asked in the question. August 20 up to 26. So I have to take only 26 days instead of 31 days. So divide 26 by 7. The remainder is 5 odd days. Now try to add, to sum up all these odd days, you will get 20 odd days. Divide the value by 7. You will get the remainder as 6. So 6 odd days. Effectively the remainder 20 odd days, that is, it is equal to 6 odd days. Okay, so if January 1 is Tuesday, what day is August 26? So August 26 is a Monday. Clear with this? That's all. Thank you.